Greetings all, I'm sad and I agree for this video to be made publicly available. This is my regenerative hydrogen fuel cell. So the problem facing renewables today is that renewables like wind and solar do not produce electricity in a way that it lines up with demand. So most demand for electricity is around sunset, and it's obvious why solar, which produces most of its electricity in at noontime during midday when the sun is out, won't really be able to satisfy demands around sunset on its own. Similarly with wind power varies from place to place, and it depends a lot on the weather conditions as to at what time the electricity will be produced from the wind turbines. So essentially, the problem that we have with renewables is that we need a way to store the electricity that comes from renewables. And there's a couple ways to do that. The most obvious way is to use batteries, but batteries are very expensive, and the lithium used to produce them is not renewable itself, is not infinite either. And batteries don't have the best reputation in terms of reliability. Another popular way to store electrical energy is using pumped hydro storage, where basically you use excess energy that you produce during noon, for example, when electricity is cheap, and you use that electricity to pump water into a dam. And then later in the day, you can release that water when electricity is expensive to essentially supply electricity when the demand is high. However, that solution depends on the availability of a hydroelectric dam, and it depends a lot on location as to whether or not, or geography as to whether or not that can be cheaply implemented. So, what I have for you today is another alternative to storing electrical energy. This is a hydrogen fuel cell. And essentially, what it does is it can take an input of electricity. So when electricity is cheap during noon, what we can do is we can charge it using that cheap electricity. And I'm going to hook it up right now so that it can start bubbling for us. And when you supply it with electricity on one half of the fuel cell here, you might be able to see bubbles start rising. And those are bubbles of hydrogen. So what happens is there's a chemical reaction going on in here when you supply a voltage difference across the anode and the cathode, and on the cathode side oxygen is produced, and on the anode side hydrogen is produced. So what's the point of this? Well, the point of this is that after you're done producing, or after you've produced a certain amount of hydrogen, however much hydrogen you want, you can take away the electricity from this system. So you can unplug it here, and then the hydrogen will react with the oxygen, and it will produce a current in the wire. So if I unhook this right now, we will have a voltage difference across these two anodes and cathodes. I want to give it some time to build up some hydrogen for a demonstration a little bit later. But while we wait, I want to tell you a little bit about the design decisions that were made for building something like this. So the primary material, or the primary component of this, is the cathode. So the cathode needs to be made of a catalyst material, which will allow the hydrogen reaction to take place. In this case, I used platinum because platinum is a more widely available material. It's easy to get by on a consumer level, and in reality, it is the best, the most effective catalyst for this reaction. Platinum is a little bit expensive though, and that's why there's research going into replacing it with types of germanium compounds or gallium compounds and things like that. On the other side, the anode material doesn't really matter as much. However, since this is all submerged in an electrolyte, I chose nickel for it because it's cheap and it's most importantly corrosion resistant. So it's not so easy to fall apart, or not. It doesn't rust so easily as copper or iron would in an electrolytic solution. And the third and last component is the electrolyte itself. So the electrolyte needs to be something which can conduct a specific amount of current through the liquid to allow the circuit to be completed, essentially. And from my research, I found that lye, plumbing or plumber's lye, is the most efficient for a hydrogen reaction. More commonly is salt is used. However, a lot of times you get chlorine gases from salt instead of hydrogen. So lye is what I found to be the most effective. I'm going to unplug this here for a second. And essentially, what I wanted to show you in the demo is to prove that we actually do have some hydrogen in here. So I'm going to try and set it alight if my lighter will start. A little more hydrogen than I expected, but there was a good amount of hydrogen in there. It's been running for a while, so it also looks like it blew up my cathode. So I don't think I can do another shot of this, unfortunately. It'll take some repairs. In the future, I look to add a compressor to the hydrogen side of this, which will basically, that's the most important part of the system to allow this to be actually workable. Adding a compressor to the hydrogen outlet of this system allows the hydrogen to actually be stored so it doesn't react with things while it's waiting for you to pump it back into the cathode to allow for a reaction to take place and actually produce some electricity. And the last part, or the last thing I want to talk about, is why I chose to do a regenerative hydrogen fuel cell. Because currently, what's more commonly available are monodirectional fuel cells. That's either a fuel cell that's optimized to produce hydrogen or an electrolysis based fuel cell. So it's more efficient at producing hydrogen, and you can't use the hydrogen to produce electricity in that type. And the other type is a more genuine fuel cell, which is something where it is only good at getting fed hydrogen and producing electricity. So, with a regenerative fuel cell like this, it's less efficient than either of the two types in any or in either direction. However, because currently we lack the infrastructure that, for example, other places in the world have in terms of hydrogen availability. For example, in Japan, it's very common now to have hydrogen pumps at gas stations. So we don't have that here in the United States yet. So before we get infrastructure to support fuel cells, having a regenerative one like this, where you can make your own hydrogen and then use it later, is just a way to bypass that sort of restriction. And that's the end of my demo.